Chapter 1, Lesson 7 of Pre-Calculus. Now that we've taken a look at these functions, we've looked at how to shift them, we've looked at stretches, we've looked at shrinks, we've analyzed them, we've done a lot of working with them just mathematically. Now we want to work on applying those to different situations in the real world. So this lesson deals specifically or entirely with applying these functions to applicational or real world type problems, or yes, I hate to say it, but word problems. And there's a few different things that we want to look at, some tips for how to tackle these things, and some tips on how to tackle some of these what we call classic problems that show up on standardized testings and those types of things. So we'll spend a few videos looking at some different tips you can use to help you get better at solving these word problems. So we'll look at how to deal with functions from formulas. We'll look at functions from graphs, functions from verbal descriptions, and then functions from data. So we'll take a look at functions from formulas first. And formulas are those things that you already know. Area is equal to pi r squared, or circumference is equal to 2 pi r, or the area of a rectangle is length times width, or volume, length times width times height when you're talking about a cube figure. So we're going to be working with these formulas, and I'd like you to read page 151 in your book. So take a look at that and then go ahead and come back and we'll follow the rest of the video. What I want you to notice, we talked about this last year when we introduced functions, and that is the phrase a function of. And whenever we see the phrase function of, what that is that's indicating to us what's going to be dependent and what's going to be independent. What's going to be the x value, what's going to be the y. What follows this phrase is always going to be your independent variable in the formula, whatever you're looking at. So area is a function of the radius. So the area of a circle is a function of the radius. The radius is what's independent. The radius can change from circle to circle, and the area then depends upon that. And so when you see this described in English, you're going to see this phrase function of when we're looking at function notation or function words. So this r is the independent variable. That's what changes from circle to circle, and then the area depends upon that. So the area is a radius. No, the area is not a radius. An area is a function of the radius. Now, if you're asked to define a function in terms of another variable, you need to ask yourself a couple of questions. Okay? First of all, are the variables directly related? In other words, if we're talking about area and radius, is there a direct relationship between the area and the radius? Well, yes, because we can find the area if we know the radius. However, sometimes they're not directly related. So you have to ask yourself, if they're not directly related, then is there another expression related to the figure you're talking about that involves the two variables you're looking at? So that may make you go, well, I had it, So what am I talking about here? Well, let me show you. Write the area of a circle as a function of its diameter. Well, wait a minute, diameter. Area is related to the radius. Area is not related to the diameter in any way. So how do I write the formula for getting the function or getting the area of a circle using a diameter instead of its radius? So area and diameter are not directly related. So what we have to do then is think about, well, is there another formula that I know of with circles that involves diameter and radius? And if we think about that, we do know that 2 radiuses make a diameter. So if I write that out, 2 radii equal a diameter, and then I solve it for r, I now have that r is actually equal to a diameter divided by 2. And now that I know that an r can be replaced with diameter divided by 2, I can then take d over 2 and put it in for r. So my formula now becomes a equals pi and not r squared, but there should be a fraction bar there. I don't know where those are. Let me put that in there real quick. Let me make this look a little bit nicer here. Let's see if I can do this. Can't see those. So this is the diameter, and this would be diameter. So I can actually replace the radius with what it's equivalent to using diameter, a diameter divided by 2, and then I simplify that, so I end up with diameter squared over 4 and pi. So this is just a little algebraic manipulation here. So what you need to do then, if the variables are not directly related, is think about another equation that involves the two variables you're thinking about. Solve one in terms of the one that needs to be replaced, and then you can replace it. So let's take another example. Write the area of a circle as a function of its circumference. Now wait a minute, area is pi r squared. That doesn't have anything to do with the circumference. So the r, the radius, needs to be replaced with c, circumference. So is there some other formula that I know of that circumference and radius are both involved in? And yeah, circumference is equal to 2 times pi times the radius. So if I take this equation now and I solve it for r, I come up with r is equal to c divided by 2 pi. Well, now that I know what r is, I can replace the r in this equation with this value, which has the c, and now I have a problem because my program just crashed. So I'm going to have to stop the video and start over. Okay, the program's a little jumpy, so let's try this again. So it says to write the area of a circle. Write the area of a circle, A, as a function of its circumference. And again, pi r squared does not involve circumference. Area and circumference are not directly related. So what we have to think about, I need to replace the r with this c. So is there an equation that has something to do with c and r? And if we think about circumference, we do have that the circumference is equal to 2 pi r. So here, circumference and radius are directly related, so I can solve this equation for r, and now I can replace this r with c over 2 pi. So the area then is actually going to be pi, and then instead of r, I substitute in this c over 2 pi, so that becomes that. I can then simplify this equation further. I have this pi out here, I square the c, so that gives me c squared. I square the 2, that gives me the 4, and I square this pi here, that gives me the pi squared. I can then simplify this pi right here with this pi here, leaving me that. So I can simplify this down then to the area of a circle is actually equal to, I'll put this over here, the area of a circle in terms of its circumference is equal to the circumference squared divided by 4 pi. So when you're given a formula and you have a direct relationship, it's nice and easy. When you don't have a direct relationship, then you have to define this variable. You have to think about another equation that has or involves the variable you're trying to replace, r, with the variable that you're replacing it with, in this case, c.